Yeah.
Okay. Hello, this is Lauren.
And this is Jenny. And this is our problem. Let f and g be the functions given by f of x equals e of x and g of x equals ln x. So part A says, find the area of the region enclosed by the graph of f and g between x equals 1/2 and x equals 1.
Okay.
So we drew that already. And so it's enclosed by 1/2 and 1, and then you have y equals e of x up here, and y equals ln of x over here. And by the way, this is a calculator problem, so for some of it, we'll be using the calculator. Okay, so part A is finding the area, and the area of a region is the interval from A to B of f of x minus g of x, and in this case, that's the interval from 1/2 to 1 of e to the x minus ln of x dx. And since this is a calculator problem, we just plug that into the calculator, and it gives us 1.223, or 1.222 if you truncate it. And that's part A. Part B says, find the volume of the solid generated when the region enclosed by the graph of f and g between x equals 1/2 and x equals 1 is revolved about the line y equals 4. Okay, so in this we're using the volume equals pi from A to B, which is 1/2 to 1 of k minus bottom squared minus k minus top squared. So k is 4 because it's the line that we're revolving around. And I'll let her finish writing that.
So that's the equation we're going to use.
Yeah.
And then when we plug in our points, it'll be pi, the integral from 1/2 to 1,
of 4 minus ln of x squared minus 4 minus e of x squared dx.
And 4 is the line that we're revolving around.
And basically from there, you also just plug it into the calculator, and you get 23.609.
And that's parts A and B. So I'm going to erase it for part C because part C is a little long.
Okay, and while she does that, I'll read it. Part C is, alright, so part C is, let h be the function given by h of x equals f of x minus g of x. Find the absolute minimum value of h of x on the closed interval 1/2 to 1. And find the absolute maximum value of h of x on the closed interval 1/2 to 1. Show the analysis that leads to your answers. Right.
Okay. So in order to do this, we're going to have to take the derivative of the two functions that were given to us. So right now our problem looks like this. It's h of x is equal to f of x, f of x minus g of x. And in order to find the critical point, we need to take the derivative of this function, and this function is merely e to the x minus ln of x. So the derivative of this is equal to, the derivative of e to the x is just e to the x, and the derivative of ln of x is 1 over x. So then we need to set this equal to 0 to find our critical point. And since this is a calculator problem, you could just put it into your calculator. So for y1, you put in e to the x minus 1 over x. And then you press graph, and then you should get something like that. And then you use second calc, and then you go to 2 for 0. And then you find your left bound, and go up, and you find your right bound. And click enter. And you get the value 0.567. So our critical point is equal to 0.567. 7. But since maxes and mins happen at critical points and endpoints, we need to plug in our critical point into our value, and we also need to plug in our endpoints, which are 1/2 and 1, into our equation to see which one yields out a max or a min. So when we do that, we plug in our critical point, which is 0.567 in place of x, and that equals 2.330. Then we plug in 1/2 in for x, and this equals 2.3418. And last, we plug in 1 for x, and it equals 2.718. So therefore, the absolute max is equal to 2.718, and the absolute min is equal to 2.330. And that's our problem. Thank you guys for watching.
Hope you enjoyed it.
We know we did.
Go calculate!
Yay!